Hey everybody, welcome to topic number 13. This topic is called linear regression and correlations. So I'm going to explain what those two words are. So this objective, we're going to talk about scatter plots, linear correlation coefficient. Okay. So what is a linear correlation coefficient? It actually measures the strength and the direction of the linear relation between your x and y variable. So basically, when we collect data, right, we want to see if it has any linear correlation to it. Okay, so this linear correlation coefficient, we using later R, measures the strength and the direction, okay, of the x and y variable. All right, your linear correlation coefficient R is always between -1 to 1. +1 means perfect positive linear relation. Okay, so it's almost like the perfect straight line. Okay, your data actually creates this perfect straight line. It's so we call that 100% fits. Okay, it's perfect. -1 means is a negative linear relation. It's going downward, perfect straight line. Okay, but when we collect data, it's not going to be 100%. I'm saying perfectly, in line like that. So if correlation coefficient R is close to 1, the closer to 1, the better. That means the stronger of the linear relation. Okay. So from this picture, you can see, some of these pictures, these are called scatter plots. Some of these scatter plots, it's not even close, right? To have a linear relation. Okay. So if R is closer to 0, or it means little or no linear relation. Maybe there's other types of relations involved. Okay. All right. This thing called a least linear regression, or sometimes we call them least square regression line. It's basically a linear line that minimizes the sum of the square errors or residuals. In other words, this linear line is a best line that fits through the data. It's called the goodness of fits. Okay, so we're using this picture right here. Okay, the linear regression will be a straight line, okay, that best fit through the entire data. Okay, so the residual, the error is the distance, okay, from each point to the line. Okay, those are your least square, your square error or residuals. All right, the symbols that we're gonna see, okay, for this linear regression is basically straight line. So sometimes we're gonna see y hat equal to mx plus b, which is your slope intercept form, okay, for the linear line. So m is your slope, b is your y value of the y-intercepts. Okay, so sometimes the calculator use different symbol. They use a for slope, what I'm saying. Sometimes they can use b for slopes. So so whenever you see where the x, the number in front of x is always going to be the slope, right? And another term behind the mx term, that's always going to be the y-intercept. All right, so here are the steps. The first 8 steps is basically show you how to use a calculator to compute the linear regression. Okay, from step 9 and 16, that's showing you how to graph. Okay, that shows how to graph the scatter plot along with your linear regression. Okay, so in a minute, the example I have, we will actually figure out what our linear regression is, and then we'll go ahead and graph the scatter plot and the line. We'll all do all that one time. All right, the following data give the number of hours of 10 students spent studying and their corresponding grades. So we're trying to see if there's a linear relation. Basically saying that if we, as the time studying for the exam, the more hours that we study for the exam, the higher the grade. We're trying to see if there's a linear relation for that. Okay, so use the graphing calculator to calculate that correlation coefficient R. So before we do that, I want you to do this. Okay, this word called catalog. Press second catalog. We need to turn something on. On the top right hand corner, that word alpha, right? I want you to find the letter D. So right now it's alphabets. We want to find the letter D. So my alphabet is in green. So I'm going to press that and go down. Look for something called diagnostic. Okay, so point the cursor right next to diagnostic on, press enter and press enter. Okay, so now the diagnostic is on, so the calculator can calculate the correlation coefficient. All right, so I'm just gonna follow the step that I listed above, okay? So first thing, go to stats, choose edit. Let's enter the hours of spent studying under L1. So that's my variable X. So my entire X-axis is about hours of studying. The Y-axis or the L2 will be the grades. Let's go ahead and type those in. What the grades? Okay. So once we've done that, let me scroll back up real quick. Once I enter it, press stat again, highlight the word calc, and choose the one that says linear regression, AX plus B, number 4. All right, press enter. There you go. So this R right here is your linear correlation coefficient R. So it's about 0.98. So the fit is almost, you can almost like saying it's about a little bit over 98% fitness. Okay. It's called the goodness of fit. So use a graphing calculator for the correlation coefficient R. So 4 decimal place, that will be 0.9817. So that's very good fits, right? It does show a linear relation. Remember, when we collect data, it's very rarely we have a perfect fit with where R is equal to 1. Use the calculator to estimate the slope. So AX plus B, right? A is your slope, okay? B is your y-intercept. So A is 6.598 something. Okay, 1 decimal place, so it'll be about 6.6. So slope is using letter M. You can use A, but normally when it comes to linear regression, we use Y hat equal to MX plus B. We use this symbol more often. So 1 decimal place, so that'll be 6 point, don't be careful now, A is your slope here, 6.6. All right, the graphing calculator to find the Y, estimate the y-intercept. So y-intercept is a point. So you got to write them as a coordinates, 1 decimal place. So this is about 61.3. So that'll be 0, 61.3. That's your y-intercept. Right, y-intercept is a point. It's on the y-axis where x is 0. Here's my y value. So basically, in a way, we are saying that if you spend 0 hour of studying, okay, it's estimated that your grades is about 61.3 based on the data, that we have. All right, substitute the correct answer from number 2 and 3 into the equation for the linear regression to estimate the linear model. So the linear model, all right, we're going to use this y hat equal to mx plus b. So your estimated regression line is 6.6x plus your y-intercept 61.3, right? B is the y value of the y-intercept. And number 5 says use a graphing calculator to draw the scatter plot in the given data above. The reason why I want to show you this because there is on the homework, there is a question where you need to take a look at the scatter plots. So you got to have this linear regression on the calculator, right? Nothing else typed. So the next thing you do, okay, once you got the regression, press enter. Don't type nothing else. Press y equal. Okay, and then press the word vars. Go to y vars to the right. Choose, oh, excuse me, vars, y equal vars, and choose statistic. I'm sorry, go back, choose number 5, statistics, and highlight the word EQ. And number 1, choose regression equation. Okay, oops, darn it. Okay, y equal vars. Number 5, EQ, linear regression. There you go. So what it does is print the entire linear regression that from the home screen onto the y equal. Okay. So now turn on the scatter plot. So second stat plot. So I'm going to use the first one. Okay. So let's turn it on the scatter plot. The first one is a scatter plot. Okay. So my X list is on the L1, my Y list on the L2. So now it's turned on. See the word on is blinking. So that's on. Press zoom and choose something called zoom stat. It's in the very bottom, number 9. There you go. That's my scatter plot. And this line right here is my linear regression. Okay. So so this line is the goodness of fit is the best line to fit through this entire data. Okay. Try another one. Okay. All right, the following data gives a list of price and number of bids received for 5 randomly selected items sold through online auctions. Use a graphing calculator to calculate the correlation coefficient R. So the price in dollars is going to be our x-axis. The number of bids is going to be the y. It's going to be under the L2 or the y-axis. So let's go back to stat and edit. Let's clear this out. And go up to on L1, press clear. Don't press delete, press clear. So let's type this in 23, 26, 28, 34, 49. 1, 2, 5, 9, 10. Kind of weird, right? As the price goes up, more bids, right? All right, go back to stat, highlight the word calc, choose number 4, linear regression. There you go. Okay, so my correlation coefficient R is about 0.8820. Okay, so it's about 88.2% fit. You know, the linear relation is about 88.2%. Still pretty good. Still pretty good. Still linear-ish. You know, well, very, not compared to not, it's not 0.9 something. All right, estimate our slope M. Slope M is the letter A. Okay, 1 decimal place, so it'll be 0.3. And the y-intercept is the coordinates 0, comma. Y-intercept, y-intercept is negative 5.6. Okay. So that means if it's $0, it's gonna be negative 5.6 bid. Okay, so that's kind of impossible, right? You cannot have negative bids. So problem like this, I'm saying, graph like these, application problem like this, if there's no dollar, then there's no bid. So basically your line should start around the origin. But based on the data we collected, okay, this is the estimated y-intercept. All right, number 4, substitute the correct answer from 2 and 3. So y hat equal to m 0.3x plus b, which is minus negative 5.6. So that will be minus 5.6. So let's take a look at the picture, okay? So with this right here, with the linear regression on the calculator, the next thing you press is y equal. Let's clear that out. All right, we go to vars, number 5 statistics, highlight EQ, choose number 1, and let's go to zoom, right? I already turned the scatter plot. Zoom, number 9, zoom stat. It recalculates. So actually, as you can see, this picture is not quite as what? This scatter plot is not as, the distance from each point to the estimated regression line, okay, is a little bit further out, right? It's not as tight, I'm saying? These points are not as close to the regression as the previous one. There you go, linear. This is your linear regression. Best line to fit through the data. All right, question number 1, 2, and 3 is basically coming from the handouts. Number 4, do the same thing. Okay, here are the hours, here are the grades. Okay, so do the same thing as I just did. Choose A or B. Okay, so it's not it is a multiple choice, but it's not, you actually have to hand type. number 5, you're gonna do A or you're gonna do B. You're gonna hand type the answer for number 5. All right. So just real quick, showing you what a linear correlation coefficient is and what a linear regression is. So trying to see if our data, has any linear relation to it, and which our linear correlation coefficient R determines how good that, how strong that relationship is. And the regression is your best line that fit through the entire data. And we call that the goodness of fits. All right, thank you for watching.